Welcome to the Java OCP 21 certification series on this channel. My name is Autoboxing and I am from ClusterMicro Technologies. We have built Java certification practice platforms earlier. So our OCA platform at javalearn.clustermicro has over 1600 practice questions, and our OCP 21 platform is also coming soon. So this series on YouTube is built around the Oracle Certified Professional Java AC21 Developer Exam code 1Z0-830. This is the professional level Java certification, one step above OCA, and it tests you at significant deeper level. So let me be direct about who this series is for and who it is not for. Okay, so this series is for you if you already know Java fundamentals, if you know what the class is, what a method is, how a loop works, and what exception is. You are ready for this particular series. We'll not be explaining what a variable is here, right? So we'll not be teaching Java from scratch here. This series is not for complete beginners. If you are just starting out on Java, so go to our OCA series first, build the foundation, and then come back. So what this series is, it's a focused exam accurate walkthrough of every objective of the 1Z0-830 syllabus for Java 21. Okay. Every slide, every code example, every speaking note in this series is built specifically around what Oracle actually tests, not what is interesting, not what it is useful in real projects. Okay, so what Oracle puts in the exam, that's the focus. You'll notice that we spend a lot of time on things that look simple, strings, integers, dates, etc. That is intentional. Oracle does not test whether you know these things exist. Oracle tests whether you know the edge cases, the compiler behavior, the runtime exception, and the subtle traps that the experienced Java developers still get wrong. Okay, the format of every video is the same. We cover the concept, we walk through the code line by line, and we call out the exact exam traps at every step. At the end of each video, you will know not just what the code does, but precisely why and what a slide variation would produce instead. The OCP 21 exam has approximately 50 questions. You need around 68% to pass. Every topic we cover here is worth marks. So there are no throwaway slides. So let's get started. Okay. In this section, we are going to cover handling values, primitives, and wrapper classes, and integer cache. So before we look at any code, let me explain why this slide matters, right? Java has two worlds, the world of primitives and the world of objects. Primitives are the raw values stored directly in memories, and objects are references that point to something on the heap. Wrapper classes are the bridge between these two worlds. Okay, so every primitive has exactly one wrapper class. So if you go through this left column, right, so you see that byte maps to byte with capital B, then short maps to short, capital S, int maps to integer. So notice that the name is not int, it is integer. This catches people out, okay? And long maps to long, capital L, float maps to float, capital F, double maps to double, capital D, but char maps to character. Again, not char, it is character. So the name changes significantly here. And boolean maps to boolean with a capital B, okay? So two pairs to memorize because the names change unexpectedly, okay? So int to integer and char to character. The others just capitalize the first letter, okay? So if we go through this code block on the right side, first we see that integer a is equal to 10, right? So here we are declaring a variable of type integer. That is the wrapper class and object, and assigning the primitive value 10 to it. Now 10 is the primitive int, and you cannot directly store a primitive int into an object variable. So what does Java do behind the scenes? The compiler automatically inserts a call to integer.value of 10 within bracket 10. This creates an integer object wrapping the value 10, and that object is what gets stored in a, the variable. Okay. This invisible conversion from primitive to wrapper it's called autoboxing. The box is the wrapper object. Okay. Java is boxing the primitive into an object automatically. You write integer a is equal to 10, but the compiler actually executes integer a is equal to integer.value of within bracket 10. Okay. Then we come to unboxing. If you see the second line, we see int b is equal to a, right? So now we go to the other direction. A is the integer object. We are assigning it to b, which is a primitive int. Again, you cannot directly put an object into a primitive variable. So the compiler automatically inserts a call to a.intValue bracket. So this extracts the raw integer value from inside the integer object and stores it in b. This is called unboxing. Java is unboxing the value out of the wrapper object. So you write intb is equal to a, but the compiler actually executes intb is equal to a.intValue bracket. So far so good. So autoboxing and unboxing happen very silently and everything compiles. Now if we see integer x is equal to null and then int y is equal to y, right? This leads to a problem. What happens is that now is actually it's a tricky part of the exam. So line 1 integer x is equal to null and this is completely legal. Integer is an object type. Object variables can hold null. So x is now a reference pointing to nothing. Line 2 int y is equal to x, right? This looks very innocent, but we are assigning x to a primitive int. As we just learned, compiler inserts x.int value automatically. But think about what that means. We are calling int value bracket, right, on x, and x is null. You cannot call a method on null, right? So that is like asking nothing to do something. And at runtime, not at compile time. So the code compiles perfectly fine, but at runtime, Java throws a null pointer exception. This is the number one autoboxing trap on the OCP exam, right? We have to remember. And autoboxing to collections, if you see, then list integer list is equal to new array list, okay? And then list dot add 42, and then intVal is equal to list dot get 0, right? This is where autoboxing happens most often in real code, and the exam tests this too. So line 1, we create a list integer, right? A list of integers, and notice that the angle bracket says integer, not int. Collections in Java can only store objects. They cannot store primitives. So we must use integer here. And line 2, we see list dot add 42, right? So we are passing the primitive 42 to add. But add expects an integer object. The compiler automatically boxes 42 into integer dot value of 42 and passes that into object in. This is autoboxing happening as a method argument, right? And in line 3, int value is equal to list.get. So get returns an integer object and we are storing it in a primitive int. Again, the compiler automatically calls .int value on the returned object. This is unboxing happening on a method return value, okay? So in just 3 lines, we have autoboxing on the way in and unboxing on the way out, okay? And if any element in that list were null, the unboxing on the line 3 would throw a null pointer exception. Then we are going to discuss about integer cache, right? So before we read a single line of code, let me explain why this integer cache exists at all, right? So in Java programs, small integer values like 0, 1, 2, 10, 100 are used constantly in loops, in counters, in comparisons. So if Java created a brand new or integer object every single time you autobox to one of those values, right? The heap would fill up with thousands of identical objects all holding the same number. This is wasteful, okay? So Java made a design decision. For the most commonly used integer values from negative 128 to positive 127, it pre-creates a pool of integer at startup and reuses them. This pool is called integer cache. So when you write an integer a is equal to 100, Java does not create a new object. It goes to cache and then finds the pre-built integer object holding the value 100 and gives you a reference to that. So every variable that autoboxes the value 100 gets the exact same cached object, right? So this is one very important consequence for the exam because equals on object compares references, and that is memory addresses. Two variables pointing to the same cached object will have equals return true. But two variables outside the cache range will point to different objects and equals return false, okay? So if we walk through this code, right, so we have integer a is equal to 100. When you write this, the compiler converts it to a integer a is equal to integer dot value of 100. The value of method checks is 100 within the cache range of negative 128 to plus 127. Yes, it is. So it goes to the pre-built pool and returns the cached integer object for the value 100. The variable a now holds reference to that cached object. Let us call it object x in memory. Now integer b is equal to 100, right? Exactly the same thing happens. The compiler calls the integer dot value of 100 again, and the cache check runs again, and 100 is in range, right? The same cached object is returned. So b now holds a reference to the same object x that a points to. So at this moment, at this time, what happens is that a and b are two different variable names, and both are pointing to the exact single object. And then we have integer c is equal to integer.value of 100. Here we are calling value of explicitly instead of relying on autoboxing, but the result is identical. Value of checks the cache and finds 100 is in range and it has the same cached object x, right? So we see all point to the same object, okay? And then we have line 4, system.out.println a equals b, right? It prints true. Prints true because the equals operator on objects compares memory addresses. It asks, do this variable point to the exact same object in memory? A points to object x, b points to object x, so same address, so equals returns true. Then we, in line 5, we see a equals c, right? That's also is true because same reasoning, c also points to object x, same address, true. Then we have system.out.println, then a equals b. That's also is true because equals method on integer compares the numeric value stored inside the object, not the memory address. Both objects hold the value 100, so equals returns true. So if we go to this section of outside cache range, right? So integer d is equal to 200. The compiler calls integer.value of 200. The cache checks runs is 200 within negative 128 to plus 127. So 200 is above 127, so the cache is not used here. So Java creates a brand new integer object on the heap holding the value 200. Let us call it object p, and d holds a reference to object p, okay? Then we have integer e is equal to 200. The compiler calls integer.value of 200 again and cache check 200 is out of range. Again a brand new integer object is created on the heap. This is a completely separate object from object p. Let us call this object q. E holds a reference to object q. So we now have two different objects in memory, both holding the value 200 but at different memory addresses. Then if we do system.out.println d equals c, it will print false because equals compares memory addresses. D points to object p, e points to object q. Different addresses equals returns false. This is the exam trap. The value is the same, 200 equals 200, but equals doesn't care about the value. It only cares about whether the two variables point to the same exact object, okay? They do not. So false. And then if we do system.out.println d equals c, it will print true because equals on integer compares the numeric value. So object p holds 200, object q holds 200. So values are equal, so equals return true, right? So if we go to block 3, we have explicit new word, right? So if we do integer I is equal to new integer 100, right? So when you use new keyword, you are explicitly telling Java create a brand new object right now. Do not check any cache. So do not reuse anything. So just create a new object. So even though 100 is within the cache range, using new completely bypasses the cache. A new integer object is created on the heap. So note that this constructor is replicated in modern Java. You should use integer.value of 100 instead, okay? But it still compiles and runs and the exam still tests it. And then we have integer g is equal to new integer 100. Again, new forces a brand new object. Another fresh object is created separate from f. And then we have system.out.println f equals g. It will print false. Two different objects created by new. Two different memory addresses and equals returns false. Even though both hold the value 100, even though 100 is in the cache range, new bypasses all of that, okay? Now we come to the practice question. We have what is the output? Integer a is equal to 127, integer b is equal to 127, integer c is equal to 128, integer d is equal to 128. Then we do system.out.println a equals b. Now we see that a and b both are in the cache range of -128 to +127. So obviously a equals b will be true. But then we have c equals d, and they are in one. The c's value is 128, d's value is 128, and both are out of the range. The cache range of -128 to +127, right? So that will print false. So our answer will be true/false. That is the correct answer, okay? If you got value from this video, please like and subscribe. It genuinely helps this series reach other OCP candidates who need it, okay? So if you want to practice OCA questions right now, you can go to javalearn.clustermicro.com. Over 1600 questions are there, and they are timed exams, detailed explanations, and free trial available. So OCP 21 practice questions are also coming soon. You can email ab.clustermicro@gmail.com if you want early access notification. So I'll see you in the next video. Thanks for your time.